Okay, as I said in other videos, I'm really excited. I'm gonna make some analysis of the levelized cost of hydrogen a lot better, I hope, and getting a good engine for that. And I'm going crazy with mean reversion and credit analysis and heavy models and battery analysis. I've got so many. It's for me the only thing I enjoy is talking to myself in front of the screen and then making a video because just finished the project. It was so horrible. Now, what I'm doing this time is just trying to do it something we did more slowly. This a continuation of this business with P50, P90, and possibly using a maximum debt to capital. And when we use a maximum debt to capital, possibly using different kinds of repayments, where it could be the sculpting. If you had sculpting, but you had a fixed amount of debt, you could imagine three or four different methods of doing it. I've discussed that before, but this time I'm putting a lot of circular references in it, and I'm obsessed with this issue. I know I am. I know I am. And I've criticized the copy and paste too much, probably because I have this other method. But I'm going to show you how it works and show you how you can reconcile and do both of them. Okay, so every time I'm trying to do this, I'm trying to show you both methods. Now, I've done this before, so I'm going to do that. I'm just going to redo the copy and paste very quickly, and let me see if we can do this. So I already started badly. If I press Control F3, that's all I want to press. And I'm going to paste the little list of range names. I don't really know where to do it. So I've got what we have here with this little simple model. We've got to compute the P50, P90, and the debt to capital and get the difference. And then we've got to get we can have a DSRA in all three of them. We could have three DSRAs that affect the debt sizing, at least in one of them. At least they affect the debt sizing and the debt to capital. And the DSRA can affect it can indirectly, I think, affect the interest during construction, and the depreciation on the interest during construction affects the taxes, and the taxes affect the CFADS, and the CFADS affects the debt size, and you've got some circularity. Okay, so I've got these things, and just a minute. I suppose where I did the DSRA, we have fixed P90, fixed P50. This is the P50 computed versus the P50 fixed. And what I'm going to do is let me just make it. So in this model, I've kind of gone crazy since the last time, and it's the most painful thing here. It really is painful because we did the whole debt sizing with IDC depreciation, and I promised myself not to go too much into this stuff. And then we have the uh, uh, fixed, and we get the IDC, that gives us the IDC depreciation. If we have a fixed level of debt and have to get more DSRA with this, then we'll I think have to borrow less money before and put more equity in, and it changes the interest during construction, and then we do this whole thing all over again with a different DSCR and P90. So when I put comp here, this is what I was looking at difference. We got to get a one way to do it, not the only way surely, is to fix the cash flow available for debt service, fix the IDC and all these kind of things and the sources and uses of funds, and then fix the DSRA. And after I've been through this about a zillion times, I know this is kind of standard now. The other thing I'm going to do here a little bit, but I think I'm going to wait with this, is I'm going to put a debt to capital method in. Okay, and with the debt to capital method, I have three different ways of sculpting the debt. One is with where you just stop at a minimum, one is where you use the LLCR, and one is when you use the curved DSCR. And we have to do all of this just to get the debt size. And in this ridiculously simple model with this many inputs, we're down to 400 lines on a page. And this, I don't have step up credit spreads. I don't have a commitment fee. I don't have multiple debt issues. I don't have any detailed operating expenses. I don't have fixed and variable costs. I don't have seasonality. I don't have any of this stuff, and it still is this painful. And we have so let's get the circular references in, and then I'm going to try. I'm so afraid of this. It's ridiculous. Oh my God. Oh my God, but this is good. I'm having such a peaceful day sitting in front of my computer. No big deadlines coming up except for a class, which is why I'm doing this. And peace. Let's go down and so let's begin. Let's make a circular reference. Let's make a copy, a paste. And let's do at least, I'm just going to do the first two right now. Okay. I'm not going to do all three of them. Okay. And the way I did this is, well, I'll never ever have a chance to remember those range names. So let's see if we can copy these things into the which I've done before in the last video. Let's copy them and just put them down here somewhere. Okay. And then and I color. And why? I gotta get rid of this option explicit thing. I don't know where this came from. I must have done some kind of option C. Okay. So we're gonna put do. Let's put. Uh, um, how about we'll put. Yeah, now I'm talking to myself because I want to do them all at the same time. How about do while range, and we know that oops, we're going to put the uh, 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 it's called, I'm sorry, where we have P90 difference and P50 difference. How about P50? Let's do it like this. And that's why I was talking to myself. So, absolute, how about absolute range, P50 difference? Oh, shit. And the, the P90 difference, we'll just do P50 and P90 now. We'll have to do them all in a minute. Oh, God. Okay, is less than, is not equal to 0. So we're going to try to get it all to be 0. It could be the fact that you don't want them all in. Okay, I mean you want it to be less than some really small minus number or something like that. Okay, and we remember now that so we've got the P50 difference where we put all of the stuff there, and then we'll get the P90 difference. Okay, why should I be nervous about this? I'm shaking. Okay, because I want to show you how this UDF is going to really work, and how you can justify to your boss. You're going to still do the copy and paste. Of course, of course, of course you're going to still do the copy and paste, but you're going to put the UDF right next door. And then I'm going to open some gigantic model that really is going to slow everything down, and then we're going to be able to just test the speed of all of this. And then the first thing we do is we set the fixed equal to the computed. So we put range and then and put dot value. Ooh, come on. Okay, and this I'm gonna put. I think it's really good practice to put the value in everything. I haven't done enough testing on this. I'm trying to test, large models and how long these large models really take equals, and then we'll do the same thing now. Okay, and then this will just be a whole bunch of them. And we'll start by the computed P50, and that's why I started looking at that. That's the CFADS. Okay, and if you, so we have P50 comp. See? What a waste of your time to, I feel so guilty. Okay, and then, and I'm gonna have to pause the video so you don't, okay, I have to admit this is the second or third time I've tried it. Probably more like the third. It does show you. If you're an old man like me, maybe I'm too old to be making models anymore, but it does show you that getting the range things right, putting all these separate lines in the model, that is a horrible pain. And just thinking in terms of a circular reference makes my mind blow up a little bit sometimes. So we've got a difference here. So remember what we had is we've got a difference in the CFADS, and we're going to copy this number down to here, and then I'm going to pull this number up so we can put our UDF in below. And then up here we've got some differences, and this comes from our fixed. It could come from our parallel model later, and we have some differences, and the DSRA does not give us differences, but we have the computed DSRA and the fixed, and we have a difference here. And then we have the same things in our P90 case, and I hope I didn't screw up this time. I probably did. So now I'm running it. Blah, 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 blah. Every time you have to run this, you'd have to work through all those copy and paste, and then it worked. Not that bad, really. Okay, for a little model, not really that bad. Okay, so now let's do the thing I'm really afraid of, and what I'm going to do is open a model that has the template. Now, this is a really big deal. This is a really big deal for me. Okay, and here's the. I also want to show you in just a minute. Hopefully, 18 hours ago I saved this, huh? Okay, I think this is probably going to be okay. I say with an idiotic level of confidence that is totally unjustified. But remember, the perfect is not the enemy of the good. Remember, this is going to be totally flexible where you can change any of this stuff. You can put your own variables in, you can insert this, you can move this around, and all we're going to do is link up the EBITDA, the if we had working capital, the capex, the taxes, the depreciation without IDC, importantly, the DSCR, what kind of debt to capital we want, whether we want to use the DSRA or fixed debt to capital, and then we can put as many tranches of debt as we want. Well, I didn't put 100 dimensions. Okay, I put 10. Fine. All right, if you have more. I had a project with more. But did it have more? About that. Okay, and then we put in our interest rate, and we put in our commitment fee and our debt tenor, and all these get linked up to the model. And then we can use our DSRA as whatever. Now, this is in a different model. The first thing we have to do is copy this to our model. And don't worry about that other thing that I just showed you, the zeros there. And then we say, oh, So what this thing does, I'm explaining this, I'm not so nervous about the time right now. What this thing does is it takes all of the equations and moves all the equations that you have, and I did it totally incorrectly because I said advanced example with simple cash flows. I think that's a fair statement about that one. Okay, so I'm going to copy it from our template, and our template could be your template. The idea of this is kind of like some kind of whatever open source. You can start changing the equations, and they're really easy. Please don't get obsessed with the stupid equations and think, oh no, I can't. If it says IDC equals opening balance times interest rate, you have to write that formula out instead of doing it. A couple of things. Now, it's all written in there, but you might want to add a line for some sort of advisory fee or some EPC fee or some little thing. You might want to add your own in, and you can't get intimidated by that. Okay, I'm going to try to explain that a little more. And then, so then we just copy it. And now, if you have nothing else, what you can do when you, by the way, when I copy this, and unfortunately, oops, I got to recalculate. Okay, and now the whole thing is in your model. Okay, so we've got this whole thing, and here's the idea. The idea is we can take this and copy this again with a P50 and P90, and we can go one by one and start linking up our numbers. Okay, and the idea of this is that it really should literally take just a couple of minutes. Okay, even if it's a large model, any kind of model, eventually you're going to have some capex. Okay, and eventually you're going to have some sort of EBITDA. Okay, that's not a big deal. And I know I'm repeating myself now, but this is kind of different. We're going to do this again for the uh, P50. So we're going to copy this. It's like the sum function. All it does is it makes a little function. This up here, it's called circular resolution. It's like a gigantic function. Certainly the biggest function I've ever made. Okay, and you can get all very, very flexible reports, blah, blah, blah. And then you can put your depreciation in here, which is your base depreciation. Come on, okay. And now, and whenever you change anything in the model, it's going to change it in here, and we'll just keep the tax rate flat, okay. So now we've got just about all the operations. I didn't put any VAT in. You could put VAT in, and you could get fancier, I guess, if you have some other tax things. Those you can all program. That's a subject, a little bit of a different subject. I'm going to put the maximum debt to capital in, like I did in the last video, and then I'm going to put in the DSCR, and I'm not going to completely freak out. I'm going to try to not totally freak out. Okay. And then if we wanted to put a different, zero is pro rata, so we'll leave this as 0. 100% would be all equity up front, and then we put in our debt parameters. I'm going to leave it as 100%. I'm not going to put a grace period, and then we'll put in our interest rate. When you put in the interest rate, this is the development period, so I'm going to be a little better than I was last time and get the interest rate straight from our debt schedule. Come on. Where is it? Oh, shit. There it is. Okay. Now, I'm not saying this is absolutely completely done, but what I'm trying to show you is something different than I showed you before. The upfront fees we can just take from our inputs if we want. Okay, so you just need to get a few of these things selected, and this was, what was this again? This was the tenor. That's a big one. Okay, so we can be totally flexible with the tenor. That's not that. It's this. And finally, we decide whether we're going to use sculpting or not. If we don't use sculpting, we've got to enter the repayment percentage. And then for the DSCR, we can use different methods. I'm just going to use a percentage the way I did in the model. And then I can put some development fees in. And the important thing is here, I can choose different reports. And if I want the model to operate a little more quickly, I can just minimize the reports, and I'm only going to, for now, show the debt sizing report. Okay, and then we go to our output, and since I changed the reports, I've got to click this little thing that says, give me a new format of the reports. Okay, and then it goes through and gives you the format of the reports. It's kind of interesting. Things are tiny little bit slower when you do this, and so is the circular reference, by the way. So things are a little bit slower when you when I'm recording doing a record. And then what it does is it gives you the level of the debt, and it says, okay, are we using the debt to capital or the sculpting? And this it says number 3, so we're using the DSCR input, and we have a 1.4 times input, and then we're getting things. Now I paused because I was terrified, but this look at this. The P50 gave us the 1192. It gave us the 1192. Now, what I'm going to do in a minute is copy these two sheets and do exactly the same sheets with the, I'm going to do exactly the same two sheets with the P90. And then later, we're going to do this thing where we put a different curved sculpting option in, and we can use the minimums and all of that, okay? But for right now, I'm going to show you, so that now you're going to your boss, and your boss says, what in the hell is this stupid UDF? And what you do is you go to the UDF, and we need to find the CFADS. So and remember, the CFADS is a function of the taxes, and the taxes are a function of the interest. So the CFADS that you have down here, and you can press, and it's totally flexible. You can put your own underlines in and do your own styles and all of that stuff. But now, instead of a copy and paste, we have the CFADS, and it's the same. Jesus. And then, instead of, for the debt, I guess I'll leave the debt computed, because now I hope it's all the circular references are gone. I'm not absolutely sure. And then for the sources and uses, we do the same sort of thing. We go up and get, we have a little summary page. And then our parallel model gives us the exact same number. Okay. And now it's all, the great news about this, did I already do that? The great news about this is that it's like you've done a circular reference. It's like you've already done the thing, and then instead of this applied thing right now, it takes it from the fixed, but we could take this applied thing from the parallel model instead, and you can show your boss or your CFO or whoever you want. You can show them. It doesn't really, it's the same thing. I'm going to show you. Okay, we'll do the copy and paste, but we have an option to do things a little bit differently. This is Hetty's innovation on the whole thing. And then, you know, we still have this horrible problem with the DSRA. By the way, I did something a little bit wrong. Up here where we put this fixed number, now this fixed number should come from down here from the UDF. It should not come from the other one, okay? And then we go downstairs and uh, um, we do the same thing with the DSRA, although with the DSRA, I think I just put the applied and the difference. So I put the, up here, I'm gonna just add a line for pre-COD, and this should have been fixed, uh, and this should have been a UDF. Okay, and we just do exactly the same thing. We go to the output and we just collect the period by period DSRA. That's up here, starting in this line. Okay, and it gives us the same number. And this applied one now, instead of taking it from this one, I can take it from this one. Okay, and now and then I'm going to stop here just for a minute. Okay, and and if I wanted to change, for example, if I wanted to change the tenor of the debt, let's make the tenor of the debt 18. And what we would do is we could get the amount of debt in the, did I even get that? I should have put the debt size here somewhere. Just a minute. I should have put, I suppose I'm going to put the amount of the debt size in from the UDF. Okay, and that's this. And right now, uh, when I change this, just a minute, I need to change one thing. Let's really make this implemented. So we'll implement it by doing this. And then we have no difference. Okay, and then if I just change this to, and I want to see the amount of the debt, I can go get it. Okay, I guess it doesn't really matter where you take it from, so I can change this to 17, and we can put a difference test, and let's get this difference test, and now I'm going to the model, and I'm going to get the total difference here. Okay, so that's good. Okay, it's not exactly zero, you know, if you put, I'm obsessed much more than I used to be about the tests here. Okay, and I've put a bunch of tests in the model itself. Okay, all right, now here's what we're going to do. I'm going to first test this. Now this is a big test for me. I don't know how it's going to work. I might indeed stop this video and end it. Okay, this is our optimize button. Okay, and uh, the What am I? Okay, I'm gonna pause the video for a minute because I'm gonna test it. If pretend we had a really big model. Okay. Now I have this gigantic model. I have this gigantic model behind me somewhere. And now I'm gonna increase this to 17, and it's gonna take a little while to do. Um, that's what it takes with UDF. Okay, now I'm going to put back the circuit. So again, now this comes from the fixed. When I put this applied, instead of it coming from the parallel model, it comes from the fixed. And of course, you could put a little a switch in for these. Okay, and then we're going to do the same with the DSRA. Okay, so the DSRA, again, just because this is really one of the themes of the video, we put this fixed and this applied now. Instead of coming from the UDF, it comes from the fixed. Okay, very good. And you can see just that by having this big model, it really does slow things down. Okay, and now let's this time let's change the det tenor, but after we've changed the det tenor, we've got to press the optimize button. So let's make it 18. And it's just taking a long time to just change the det tenor, okay? But then we have to run it. We don't have a gigantic big difference test, and every time we run it, it's recalculating, and you can imagine if you have a really big model, just how long this will take. And if you're in a big meeting and you're doing all of this stuff, I'm just trying to say something while it's running. And this whole circular reference business makes me so nervous anyway. I don't know why the 0.47 isn't, it finally went down here, but it's not exactly 0, so we keep going around a few more times to get it to be exactly 0. And you can see the difference in the efficiency. Oh, now I've got it back up to 0.3, and this is making me happy. This is not making me sad. It's making me happy to show you just how much more, if you've got a big model, and these models are getting big, we all know that. We're putting every pencil we've ever, well, pencils we don't have anymore. What are we putting in? Let me see if we don't call it pencils. What kind of detail on the operating expense should we put in? And we're putting how many? Oh God, how many? Oh God, I don't know what to say anymore. What should I say instead of pencils? There must be something we have to buy. Computer screens or something, but they're expensive. I don't know. Okay, well, it's going around and around. And I might think that now I've proved my point, and you should turn off the video, because when I'm finished, I'm going to turn off the video. And I am so happy. Now you could say, why didn't you, if the difference is just about 0, why didn't you stop? And I could have said yes, so we could have made the circular reference a little bit faster, but it would have still been a heck of a lot slower than the UDF, wouldn't it have? Okay. Uh, uh, and come on. I'm gonna now I'm really gonna have to pause. Okay, it finally stopped, and maybe I should have put a round in there or something else. But okay, this is enough. I'm stopping this video. I'm happy, yeah, that maybe one reason to use it is because it really it is a lot more efficient in large models. All right, and let's stop.